Hi everyone. In this lesson we're going to apply the properties of parallelograms in proofs. In other words, we're going to be writing proofs where the reasons or some of the reasons are going to be properties of parallelograms. For example, you could have one of the reasons such as opposite sides of a parallelogram are congruent or diagonals bisect each other, things like that. Or for example, all sides of a rhombus are congruent. So some of those reasons will be those properties that we learned in the last few days. So I'm going to take a look at proof number 1, and I'm going to hide the proof so that I can show it to you later after we sort of plan. So the first one says parallelogram ABCD. So that's our given. It's given to us that it is a parallelogram, and our job is to prove that triangle AED, this triangle here, is congruent to triangle CEB, which is this triangle here. And actually there are many ways to prove that these two triangles are congruent. You can use any criteria that we have learned, and there are different ways of doing it. For example, the simpler one would be using side, 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 because we could say, for example, DE is congruent to EB because the diagonals in a parallelogram bisect each other. So the same thing would be true for AE and CE. And in addition to that, we also know that in a parallelogram, opposite sides are congruent, so that would make AD congruent to BC. And so we have side, side, side in each triangle. But that's only one of the methods that we could use. We could use, for example, side angle side, since the diagonals of a parallelogram bisect each other. Those pieces would be congruent. And then we will have these vertical angles that are congruent. So we have side, angle, side. So we have side, side, side. That's a possibility. Side, angle, side is a possibility. And you could also use angle, side, angle, or angle, angle, side. So any of those, actually you could use any of those four. So you could use angle, angle, side, and angle, side, angle. I'm going to be using the fourth one just to use a different criteria for each of the exercises, because in the other exercises I'm going to be using side, 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 and side, angle, side. So I'm going to use angle, side, angle for this one. So let's see how will we do this proof using angle, side, angle. Well, we know already that the vertical angles are congruent, so we have one pair of angles, which is, say, this one. And then we know that the diagonals bisect each other. So for example, I could say AE is congruent to CE, and we have the side. So now we're just missing one angle. And we could use any of these angles that we have remaining, such as angle CBE congruent to angle ADE, because in a parallelogram the opposite sides are parallel. That will make these two angles alternate interior angles. Those are the angles that form the Z. If you're using alternate interior angles, you have to be using with the lines that are parallel. You cannot use the other pairs of sides, for example, here. Although they are parallel, that will not give us this angle congruent to this angle. Or you could say angle DAE congruent to angle BCE, for the same reason, because if AD is parallel to BC, and we know that they are parallel because in a parallelogram opposite sides are parallel, So that makes this angle here congruent to this one here by alternate interior angles. So there are alternate interior angles which are congruent. So that's information that I'm going to use for this proof. Remember that there are many ways that you can do it. You can use any way that you want as long as you have a correct way. And that's what I have here. So exactly in the same way as we plan, or you could rearrange, I think I rearrange here. So the first thing that we would say here, it's parallelogram ABCD, that's given. And the next thing that I have is segment AE congruent to segment CE, so AE congruent to CE, and that's because the diagonals bisect each other. Diagonal BD is bisecting diagonal AC. So that would be here. That's one of the properties of the parallelogram. We will not simply say property of a parallelogram. There are many properties, so we have to be specific. And here, the property that we're using is the one that says diagonals of a parallelogram. We can draw a little parallelogram that is acceptable also in the regions. Diagonals of a parallelogram bisect each other. And the next thing that I have is angle AED congruent to angle CEB. Those are the two vertical angles, so that will be the reason. Vertical angles are congruent. And then in order to mention the other pair of angles, which are the alternate interior angles here in green, I first need to mention that there are two parallel lines because alternate interior angles only come from parallel lines. So I need to mention those parallel lines here, which in this case are segment AD parallel to segment BC. And they are parallel because in a parallelogram, opposite sides are parallel. That is actually part of the definition of the parallelogram. You could say definition of a parallelogram here. Or you could write, you could say opposite sides of a parallelogram are parallel. And then because I have these parallel lines, I get from those parallel lines the alternate interior angles. The ones that I'm using here, it's DAE congruent to VCE. That's because alternate interior angles are congruent. Alternate interior angles are congruent. And since now we have, this was a side, this is one pair of angles, and this is the other pair of angles. The side is in between the angles, so I'm using side angle, side angle, sorry. I'm using angle, side, angle criteria. And that justifies the congruence of these two triangles. So that's just one way of doing it. And then I have number two. Number two says ABCD is a rhombus, so that's one given, and AE is congruent to CE. So we already know that ABCD is a rhombus. So this is the rhombus. And then in addition to that, we have that segment AE is congruent to segment CE. And our job is to prove that angle ADE, this angle here, it's congruent to angle CDE, this angle here. Okay, so if we want to prove angles congruent or segments congruent, like in this case we want to prove angles, remember that we first need to prove congruent triangles and then we will use CP/CTC. So in this case, we need, in order to prove that these two angles are congruent, we will need to prove that these two triangles, which I'm putting them in green, we need to show that these two are congruent, because that is the only way to show that these two angles are congruent. And we already have one pair of sides, and it's a rhombus. And that's very important information, because we know that in a rhombus, all the sides are congruent, because the only thing that we have from the rhombus is really the sides. So we're going to use those sides. So, and we know that the sides of a rhombus are congruent. So AD and CD, those are two sides of a rhombus. So those are congruent. And finally, we also have here DE being shared by both triangles. So by the reflexive property, we have another pair of sides that are congruent. So we have side, side, side. In this case, that's the only method to prove. There's no other way to do it. So that's the plan, and that's what I have. Actually, I have the complete proof already written down, because otherwise it will take me a very long time to write the proof as I do the video. So here it is. ABCD is a rhombus, that's given. AE congruent to CE, that's also given. And then I have AD congruent to CD. That is because those two are sides of a rhombus, and all sides of a rhombus are congruent. Or since these are consecutive sides of a rhombus, you could say consecutive sides of a rhombus are congruent. But this is good enough. And then we have DE congruent to DE, that is by the reflexive property. And then with that, which is side, 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 because here you have one pair of sides, another pair of sides, and here you have another pair of sides. Remember that when you put an S, there has to be a pair of congruent sides, otherwise don't write an S. And since I have side, 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 then I can say that these two triangles are congruent, and therefore these two angles are congruent. So angle ADE is congruent to angle CDE by CP/CTC, which is corresponding parts of congruent triangles are congruent. And that's the only way to do the proof for this one. So we have used here this property of the rhombus. Number 3, it's partially done, again, because otherwise it will take me a long time. And let's see what we have here. It says RSTV is a rectangle, and U is the midpoint of VT. So we have a rectangle. That's very important, because we are going to get some things from the rectangle. And we also have this, which we know already would give us two congruent parts if U is the midpoint of BT. So BU would be congruent to TU. So that's something that we get from our second given. What else can we get? Now, because it is a rectangle, we could get right angles all over the place. and other things, but let's see first what do we have to prove. We have to prove that triangle RUS is isosceles. I think we have never done this before, and proofs can actually get very complicated. This is actually a relatively simple proof, but they could get very complicated. But what would you need to prove? What would you need in order to prove that a triangle is isosceles? You have to see what does the definition of an isosceles triangle say, and the definition says that a triangle is isosceles, or an isosceles triangle is a triangle that has two congruent sides. So in order to show that you have an isosceles triangle, you need to show that it has two congruent sides. That's what you need to show. So in this case, we want to show that this triangle is isosceles. So you need to prove that it has two congruent sides. Those two congruent sides are obviously going to be RU and SU. So our job really here is to show that this piece is congruent to this piece. If we get to show that these two segments are congruent, then we will conclude that this is an isosceles triangle. So now we will ask ourselves, how do we prove that these two segments are congruent? Well, the only way to prove that segments are congruent is by proving that two triangles are congruent. So we actually need to prove that this triangle RBU is congruent to triangle STU. So we need to show that these two triangles are congruent. And what we have in order to prove that these two triangles are congruent, the only thing that we have so far is that BU is congruent to TU. And then we can get other things from the fact that we have a rectangle. For example, as I said before, we have right angles all over the place. And specifically here at B and at T, we have right angles. And there is a theorem that says that all right angles are congruent, so you could actually prove that these two angles are congruent. So we already have side angle. And also, in a rectangle, opposite sides would be congruent because a rectangle is a parallelogram, and in a parallelogram, opposite sides are congruent. So RB and ST would be congruent. Because a rectangle is a parallelogram, and in parallelograms, the opposite sides are congruent. Here we will simply say the opposite sides of a rectangle are congruent. So now we have side, angle, side. With this, we show that these two triangles are congruent. And after that, we can say that these two sides are congruent by CP/CTC. And after that, we're going to say that this triangle is an isosceles triangle because it has two congruent sides. So let's look at the proof. So here it is, partially done. So it says RSTV is a rectangle and U is the midpoint of TV. So that's given. And then we have BU congruent to TU. That's because we have a midpoint, so that's definition of midpoint. Or you could actually say that write down the definition of a midpoint. And then I have angle B and angle T are right angles, because if you want to show that two right angles are congruent, first you have to mention that they are right angles. So first I'm saying that they are right angles. And why do we say that? Because all the angles of a rectangle are right angles, or a rectangle has 4 right angles. So let's say a rectangle has 4 right angles. And then we know that all right angles are congruent. And that's why angle B is congruent to angle T. And then I have RB congruent to ST. That's because opposite sides of a rectangle are congruent. Opposite sides of a rectangle are congruent. And with that, since we have side, angle, side, we can say that the two triangles are congruent by the side, angle, side criteria. And then, since the two triangles are congruent, RU is congruent to SU by CPCTC. And finally, we can conclude that triangle RSU is isosceles. And we could say it here, definition of an isosceles triangle, although we will actually be using the converse of the definition. So if two sides of a triangle are congruent, then the triangle is isosceles will really be what we should be writing. But I'm just going to write definition of an isosceles triangle. So in this case, we have used the fact that a rectangle has right angles. That's one of the properties that we use. We also use this other property of rectangle, the fact that opposite sides are congruent. So that's how we use properties of parallelograms in writing the proofs. Of course, not all the reasons are going to be properties. Some of them, like in this case, we have two. So that's it for today's lesson on writing proofs using the properties of parallelograms. As always, check the website to see what is the homework.